Hello everyone, welcome to Solo Survivor. Now it's my time to read books. So, oh, if you want to ask me anything, then you can put that comment or question in the comment section. I'll be responding the question afterwards while I finish up reading. Now it's time only for reading. Important laws, theories, and their scientists' laws, theories. Gravitational law, laws of motion, scientist that is Newton. Theory of relativity, Albert Einstein. Discovery of X-ray, W.C. Roentgen. Principle of lever relative density, Archimedes. Kinetic theory of temperature, Kelvin. Theory of an atom, Dalton. Laws of electrolysis, Faraday. Important scientific instruments. Instrument use altimeter. It measures altitudes and is used in aircrafts. Ammeter. It measures strength of electric current in ampere. Electric current in ampere. Audiometer. It measures intensity of sound. Barometer. It measures atmospheric pressure. Binocular. It is used to view distant objects. Calorimeter. It measures quantity of heat. Cardiogram. It raises movements of the heart recorded on a cardiograph. Cardiogram. Chronometer. It determines longitude of a place kept on board ship. Cinematography. Chronometer. It determines longitude of a place kept on board ship. Cinematography. It is an instrument used in cinema making. Dynamo. It converts mechanical energy into electrical energy. Dynamometer. It measures electric powers. It measures electric power. Dynamometer. Electrometer. It measures electricity. Electroscope. It detects presence of an electric source. Endoscope. It examines internal parts of the body. Pedometer. It measures the depth of the ocean. Instrument use. Galvanometer. It measures the electric current of low magnitude. Hydrometer. It measures the specific gravity of liquids. Hygrometer. It measures humidity in air. Hydrophone. It measures sound underwater. Lactometer. It determines the purity of milk. Manometer. It measures the pressure of gases. Mariner's compass. It is an instrument used by the sailors to determine the direction. Microphone. It converts the sound waves into electrical vibrations. Microscope. It is used to obtain magnified view of small objects. Microscope. It is used to obtain magnified view of small objects. Odometer. It is an instrument by which the distance covered by wheeled vehicles is measured. Wheeled vehicles measured. Phonograph. It is an instrument for producing sound. Photometer. This instrument compares the luminous intensity of the source of light. Periscope. It is used to view objects above sea level, used in submarines. Radar. It is used for detecting the direction and range of an approaching plane by means of radio microwaves. Radiometer. It measures the emission of radiant energy. Seismograph. It measures the intensity of earthquake shocks. Selenometer. It determines salinity of solution. Spectrometer. It is an instrument for measuring the energy distribution of a particular type of radiation. Speedometer. It is an instrument placed in a vehicle to record its speed. Sigma manometer. It measures blood pressure. Sigma manometer. It measures blood pressure. Sphygmometer. Sphygmomanometer. Spirometer. It measures the curvatures of surfaces. Spirometer measures the curvatures of surfaces. Stereoscope. It is used to view two-dimensional pictures. Stereoscope, two-dimensional pictures. Stethoscope. Stethoscope, an instrument which is used by the doctors to hear and analyze heart and lung sounds. Stroboscope. It is used to view rapidly moving objects. Stroboscope. It is used to view rapidly moving objects. Tachometer, an instrument used in measuring speeds of airplanes and motorboats. Tachometer. Telescope. It views distant objects in space. Thermometer. This instrument is used for the measurement of temperatures. Thermostat. It regulates the temperature at a particular point. Voltmeter. It measures the electric potential differences between 2 points. Voltmeter. It measures the electric potential differences between 2 points. Inventions and discoveries. Invention year, inventor, country. Adding machine year 1642. Inventor Pascal, country France. Airplane 1903. Orville and Wilbur Wright, USA. Air conditioning 1902. Carrier, USA. Airplane jet engine 1939. Ohen, Germany. Airship non-rigid 1852. Henry Giffard, France. Atomic bomb 945. J. Robert Oppenheimer, USA. Ballpoint pen 1888. John J. Loud, USA. Barometer 1644. Evangelista Torricelli, Italy. Battery electric 1800. Alessandro Volta battery, electric battery, 1800. Alessandro Volta, Italy. Bicycle, 1832-40. Kirkpatrick Macmillan, Britain. Bicycle tires, pneumatic, 1888. John Boyd Dunlop. John Boyd Dunlop, Britain. Bifocal lens, 1780. Benjamin Franklin, USA. Bleaching powder, 1798. Tennant, Britain. Bunsen burner, 1855. R. Wilhelm von Bunsen, Germany. Burglar alarm, 1858. Edwin T. Holmes, USA. Camera, Kodak, 1888. Walker Eastman, USA. Car, steam, 1769. Nicolas Cagnot, France. Car, petrol, 1888. Karl Benz, Germany. Carburetor, 1876. Gottlieb Daimler, Germany. Gottlieb Daimler, Germany. Carburetor. Cassette videotape, 969. Sony, Japan. Cement, Portland, 1824. Joseph Aspdin, Britain. Cinema, 1895. Nicholas and Jean Lumiere, France. Clock, mechanical, 1725. Icing and clock, pendulum, 1656. Christian Huygens, Netherlands. Compact disc, 972. RCA, USA. Compact disc player, 979. Sony Philips, Japan, Netherlands. Sony, Japan, Philips, Netherlands. Computer, laptop, 987. Sinclair, Britain. Computer Mini, 960. Digital Corp, USA. Diesel engine, N95. Rudolf Diesel, Germany. Dynamo, 1832. Hypolite, Pixie, France. Electric flat iron, 1882. Etsy, Chile, USA. Electric lamp, 1879. Thomas Alva Edison, USA. Electric motor, DC, 1873. Genob Graham, Belgium. Electric motor, AC, 1888. Nikola Tesla, USA. Electric iron, 1882. Henry W. Shelley, USA. Electric washing machine, 1906. Alpha J. Fisher, USA. Electromagnet, 1824. William Sturgeon, Britain. Electron, 1897. Thomson J. Britain. Electroplating, 1805. Luigi Brugnatelli, Italy. Electronic computer, 1824. Dr. Alan M. Turing, Britain. Alan M. Turing, Britain, in 24. Pacer mill machine, 1843. Alexander Bain, Britain. Fiber optics, 1855. Capani, Britain. Film Moving Film Moving Outlines, 1885. Louis Prince, France. Film Talking, 922. J. Engel, J. Muschel, and It's Vogt, Germany. Galvanometer, 1834. Andre Marie Ampere, France. Gramophone, 1878. Thomas Alva Edison, that is Gramophone, Thomas Alva Edison, 1878, USA. Helicopter, 1924. 18 Omicin, 18 Omicin, 18 Omicin, France, that is helicopter. 1924. Hydrogen bomb, 1952. Edward Teller, USA. Invention year, inventor, country. Intelligence testing, 1905. Simon Binet, France. Jet engine, 1937. Sir Frank Whiting, Britain. Leisure, 1960. Theodore Maiman, USA. Launderette, 1934. J.F. Condrell, USA. Lift, mechanical, 1852. Elisa G. Otis, USA. Lighting conductor, 1752. Benjamin Franklin, USA. Loudspeaker, 1900. Horace Sword, Britain. Machine gun, 1918. Richard Gatling, Britain. Magnetic recording tape, 1928. Fritz Plummer, Germany. Microphone, 1876. Alexander Graham Bell, USA. Microscope, 1590. Jet Jensen, Netherlands. Microscope, 931, that is electric. 931, Ruska Knoll, Germany. Microwave oven, 947. Percy LeBaron Spencer, USA. Motorcycle, 1885. Z. Daimler, Germany. Movie projector, 1893. Thomas Edison, USA. Neon lamp, 1910. George's clothes, France. Neutron bomb, 1958. Samuel Cohen, USA. Optical fiber, 1955. Narinder Kapani, Germany. Pacemaker, 1952. Joel, USA. Photoelectric cell, 1893. Julius Elster, Hans F. Gettel, Germany. Photography on metal, 1826. Jean Nips, France. Photography on paper, 1835. W. H. Fox Talbot, Britain. Photography on film, 1888. John Carwood, USA. Piano was invented in 1709 by Cristofori of Italy. Pistol or revolver 1836 called USA. Radar 1922 A.H. Taylor and Leo C. Young USA. Radiocarbon dating 1947 Libby USA. Radio telegraphy 1864 Dr. Mulholland Loomis USA. Radio telegraphy transatlantic 1901 G. Marconi Italy. Rion 1883 Sir Joseph Swan Britain. Razor electric 1931 Kolchikov Sikh USA. Razor safety 1895 King C. Gillette USA. Refrigerator 1850 James Harrison Alexander Catlin USA. Rubber latex foam 1928 Dunlop Rubber Co. Britain. Rubber tires 1846 Thomas Hancock Britain. Rubber Vulcanist 1841 Charles Goodyear USA. Rubber waterproof 1823 Charles McIntosh Britain. Safety fin 1849 Walter Hunt USA. Ship steam 1775 IC Perrier France. Ship turbine 1894 Hornsharsey Parsons Britain. Steam engine 1698 Thomas Savery Britain. Steam engine piston 1712 Thomas Newcomen Britain. Steam engine condenser 1765 James Watt Britain. Steel stainless 9 Turin Harry Brearley Britain. Stethoscope 1819 Laennec France. Submarine 1776 David Bushnell USA. Supercomputer 1976 J.H. Van Tassel USA 1976 supercomputer. Tank 1914 Sir Ernest D. Swinton Britain. Tape recorder 1899 Passenden Poulsen Denmark. Telegraph 1787 M. Lemont France. Telegraph code 1837 Samuel F. B. Morse USA. Telephone cellular 1947 Bell Labs USA. Telephone imperfect 1849 Antonio Meucci Italy. Telephone perfected 1876 Alexander Graham Bell USA. Telescope 1608 Hans Lippershey Netherlands. Television mechanical 1926 John Logie Baird Britain. Television electronic 927 P.T. Farnsworth USA. Television color 928 John Logie Baird Britain. Transformer 1831 Michael Faraday Britain. Transistor 1948 Bardeen Shockley and Britain USA. Transistor radio 955 Sony Japan. Uranium fission atomic reactor 942 Szilard Fermi USA. Vacuum cleaner electronic 1907. Spangler, USA. Videotape, 1956. Sulz, Ginsburg, USA. Washing machine, electronic, 1907. Harley Machine Co., USA. What's 1462? Bartolomeo Manfredi. What's Bartolomeo Manfredi, 1462? Italy. Wireless telegraphy, 1896. Marconi, Italy. Now comes chemistry, matter and its states. Matter, states. Matter and its states. Matter is anything which has mass and occupies space. It exists in 5 states: solid, liquid, gas, plasma, and Bose-Einstein condensate. Solid, liquid, gas, plasma, and Bose-Einstein condensate. Bose-Einstein condensate, out of which the former three are commonly seen. States of matter. The 5 states of matter are discussed below. Solids. They have definite volume and definite shape. They are incompressible, and have strongest intermolecular interactions. They are very dense as compared to liquid and gas, wood, stone, iron, etc. Melting point. It is a temperature at which a substance converts from its solid state to liquid state. Melting point of ice is 0 degrees Celsius. Melting point decreases in the presence of impurity. Sublimation. It is the process of conversion of a substance from the solid state to the gas state. From solid state to the gas state. Formation is called sublimation. That state without passing through an intermediate liquid phase. Without passing through intermediate liquid phase, but directly solid to gas. That is called sublimation. It is used to separate a sublimate or substance undergoing sublimation like camphor, naphthalene, ammonium chloride, etc. from non-sublimate liquids. They have definite volume but no definite shape. They take the shape of the vessel in which they are kept. They can flow, hence considered as fluids, milk, water, mercury, etc. Boiling point. It is a temperature at which vapor pressure of a liquid becomes equal to atmospheric pressure, and at which a substance converts from its liquid state to gaseous state. It is about or it is different at different places. Boiling point of water at normal conditions is 100 degrees Celsius. It usually decreases at high altitudes. That's why at high altitudes the boiling point of water is less than 100 degrees Celsius. Less than 100 degrees Celsius, and more time is required to cook a food. The boiling point of water is less than 100 degrees Celsius. More time is required to cook a food. Boiling point of water in pressure cooker is high due to high pressure, and hence less time is required to cook the food. Boiling point increases in the presence of impurity. Evaporation is the process of conversion of A liquid into vapors at any temperature below its boiling point. It increases with increased interface area and temperature. It provides cooling. That is why we feel cool when some nail polish remover or spirit is kept on our palm. Gases. They have neither definite volume nor definite phase shape. They take the shape and volume of the container in which they are filled. They are highly compressible. They are highly compressible. Gases are very much highly compressible. They can flow, so considered as fluids, air, oxygen, and nitrogen. Condensation. It is the process of conversion of gas into liquid or liquid into solid. Gas into liquid or liquid into solid. That is called condensation. Solids, liquids, and gases are interconvertible by changing the conditions of temperature and pressure. Solid, heat or cool, liquid, heat or cool, gas. Plasma. The fourth state of matter is called plasma. This state contains ionized gas with super energetic and super excited particles. Fluorescent tube contains helium gas and neon gas. Shine bulb contains neon gas. Bose-Einstein condensate in 924 to 25 Cylindronaut Bose and Albert Einstein gave the information. Cylindronaut Bose and Albert Einstein gave the information about Bose-Einstein condensate. It is a state of matter of a dilute gas of boson cooled up to temperature which is very close to absolute zero or minus 273.15 degrees Celsius. In fact, it is a fifth state of matter. Particles of matter, atoms. It is the smallest particle of matter that takes part in chemical reactions by Dalton's atomic theory. It can neither be created nor destroyed. A law of conservation of mass given by Lavoisier. It does not exist in free state on the hand has a fixed atomic mass. Iron, gold, iron, iron, gold, AU, silver, is etc. It doesn't exist in the free state and has a fixed atomic mass. Etc. That is iron, gold, silver. Molecules. These are the smallest part of the matter that exist in free state. They are formed by the joining of two or more atoms in fixed ratio. Law of multiple proportions given by Dalton. They have fixed molecular mass, which is obtained by adding the atomic masses of all the atoms present in a molecule. Water, H2O, ammonia, NH3, carbon dioxide, CO2, etc. Pure substances. A substance is said to be pure if all the constituent particles of that substance are the same in their chemical nature. All the elements and compounds are pure substances. Elements they contain only a single type of atoms. Elements combine to give molecules. Examples of elements are sulfur, phosphorus, oxygen, etc. Elements known at present are 118, out of which 94 are natural elements which are liquid at room temperature are mercury, Hg, and bromine, Br. Elements which become liquid at a temperature slightly above the room temperature 303 K are gallium Ca and caesium Cs. Cs Elements have the following order of evidence in early crust: oxygen, silicon, aluminum. Oxygen is greater than silicon, silicon is greater than aluminum, greater than iron, greater than calcium. Elements have the following order of evidence in human body: oxygen, carbon, then hydrogen, then nitrogen. Elements have the following order of evidence in earth crust, that is highest amount of oxygen, that is then silicon, aluminum, iron, calcium. Elements have the following order of evidence in human body, that is oxygen, carbon, hydrogen, nitrogen. Compounds. This contain more than one kind of atoms. This cannot be separated into constituent atoms by simple physical methods. Their examples are silica, SiO2, water, H2O, sugar, C12H22O11, C12H22O11, salt, NaCl, etc. Compounds. These are compounds. Silica, water, sugar, salt, these are compounds. Impure substances. A substance is said to be impure if all the constituent particles of that substance are not same in the chemical nature. Mixtures. These are obtained by mixing two or more substances in any proportion. Mixtures can be homogeneous, have uniform composition throughout salt solution, sugar solution, air through solutions, etc., or heterogeneous, have non-uniform composition, mixture of salt and sugar, colloidal solutions, etc. Solutions or true solutions. These are homogeneous mixtures of two or more substances. A solution contain two components: solute in less quantity and solvent in more quantity. Solute, that is less quantity, and solvent in more quantity. Examples of solutions are sugar solution, tincture of iodine, tincture of iodine, solution of iodine in alcohol, aerated drinks like soda water, air alloys, etc. Concentration of solution may be expressed by percentage mole, fraction parts per million, gram per liter, molality, normality, etc. Colloidal solutions. These are heterogeneous mixtures. These shall contain two phases, dispersed phase and dispersion medium. This can scatter light because of the presence of large solute particles. They show Tyndall effect and Brownian movement. The blue color of sky is also due to scattering of light by dust particles suspended in air. They are separated by a special technique like centrifugation. Colloidal solutions are coagulated by adding an electrolyte. Colloidal solutions are purified by dialysis, which is also used in the purification of blood with the help of artificial kidney machine. Coagulation found its use in purification of water by alarm, stop bleeding by VCL3, formation of delta at the junction of sea and river. They are of following types on the basis of dispersed phase and dispersion medium. Sorry. Dispersed phase and dispersion medium type of colloid. Examples: liquid dispersion phase, dispersion medium, liquid gas type of colloid aerosol. Example: fog clouds, mist. Um, Solid gas aerosol, smoke, automobile exhaust, gas liquid foam, shaving cream, liquid emulsion milk, face cream, solid milk of magnesium malt, gas solid from rubber sponge, pumice stone, liquid solid jelly cheese butter, solid that is colored gemstone milky glass. Separation of mixtures. Separation of mixtures. A number of physical and chemical methods are used to separate the number of mixtures. Some important methods are discussed below. Centrifugation: it is based upon the principle that the denser particles are pushed to the bottom and the lighter particles stay at the top when spun rapidly. It is used in diagnostic laboratories for blood and urine tests, in dairies, and home to separate butter from cream, etc. Distillation: it is a method of separating mixtures based on this volatilities of components in a boiling liquid mix. Ether and toluene, benzene and distillation. It is used to separate liquids heavy. It is used to obtain pure diesel, petrol, kerosene oil, coal oil from crude oil or mineral oil. It is used to separate a mixture of acetone, alcohol, 338K, big one, distillation. It is also used to pressure. It is used to put substances which decomposes built boiling point. It is used to concentrate sugar cane juice. It is used to separate it from non-volatile or non-steam, to purify standard or chemical, aniline, nitrobenzene, etc. কোনেও ভাল নাপায় নেকি? কোনেও এজনেও লাইক কৰে নাই এতিয়ালৈকে, নাজানো দেই কিয় বা। পঢ়াটো ভাল নাপায় নেকি? একো নাই, ভাল পাওক বা নাপাওক, যিমানে ভাল নাপাওক কিয় মইতো অকণ উদায়াৰে পঢ়িম। Displacement reactions, incest reactions, displacement reactions, incest reactions. An atom or a group of atoms of a molecule is replaced by another atom or group of atoms. Copper sulfate, ferrous sulfate. Double displacement reactions. This involves an exchange of ions between two compounds, NaCl plus AgNO3, that is AgCl plus NaNO3. Double displacement reactions. Reactions occur between the ions or ionic compounds are very fast. Exothermic reactions. These are those reactions in which energy is released. Example given: burning of natural gas. Respiration, decomposition of vegetable matter into compost, combustion reactions, etc. Endothermic reactions. These are those reactions in which energy is consumed. Digestion, photosynthesis, evaporation of water, melting of an ice, etc. Endometric reactions. Redox reactions, NSAS reactions, oxidation, and reduction occurs simultaneously. These are called disproportionation reaction when the same element is oxidized as well as reduced. Oxidation oxidation it involves addition of oxygen or any other electromagnetic element like fluorine, chlorine, nitrogen, and etc. Chlorine, nitrogen involves addition of gas or any other electromagnetic element like chlorine, nitrogen. It involves removal of hydrogen or any other electropositive element like sodium Na. It involves loss of electrons, increase in the positive source, of ion. Reduction. It involves addition of hydrogen or any other electropositive element. It involves removal of oxygen or any other electromagnetic element. It involves gain of electron, decrease in oxidation state, oxidizing agent or oxidant. These are the substances that have the ability to oxidize other substances. It's 2O2. I mean, these are draw negative elements. What do we have to Cl2, Br2, etc. Reducing agent or reductant. Reducing agent or reductant. These are the substances that have the ability to reduce other substances, transfer electrons to another substance, electropositive element metals such as lithium, sodium, magnesium, iron, zinc, and aluminum hydride, transfer reagents such as NaBH4 and AlH4, etc. Reduction plus to into this no need. Catalysis. It was discovered by Berzelius. It is the term used for the reactions processes which occur in the presence of certain substances that increase the rate of the reaction without being consumed. Those substances are called catalysts. It's a term used for the reactions processes which occur in the presence of certain substances that increase the rate of the reaction without being consumed. Those substances are called catalysts. Catalysis is called homogeneous when reactant and catalyst in Champagne for the manufacture of sulfuric acid. Catalysis is called heterogeneous when reactant and catalyst are in different phase. Haber's process with the synthesis of ammonia. I don't know these things. Periodic table. It is a table display of chemical elements organized over the basis of their properties. It contains horizontal rows called periods and vertical columns called groups. Covalent compounds. They are non-conductor of electricity. They have low thermal conductivity. They are insoluble in water but soluble in non-polar solvents like benzene, acetone, ether, etc. They have low melting and boiling points. Diamond and graphite have very high melting point. Diamond and graphite very high melting point. They are directional, so have a definite geometry. Coordinate or dative bond. Hello, please like the video. I don't have any like till now. So if you like the video, then please like the video. Means hope you have understood what I meant to say. Hello buddy. Hi. Please like the video. And it one like oh yes kind of okay no need. If you don't want to like then bye bye. That doesn't matter. Covalent compounds and they are non-conductor of electricity. They have low thermal conductivity. They are insoluble in water but soluble in non-polar solvents like benzene, acetone, ether, etc. They have low melting and boiling points. Diamond and graphite have very high melting point. They are directional, also have definite geometry. Coordinate or dative bond. It is a special type of covalent bond in which both the electrons for shared pair of are given by only one atom. Coordinate compounds have properties in different individual ionic and covalent compounds. Examples of coordinate compounds are aluminum ion, cyanide ion, hydrogen bond. It is the attractive interaction of a hydrogen atoms to highly electronegative atoms such as NFO with another electronegative atom such as nitrogen, oxygen, or fluorine. It is stronger, has energy 5 to 30 more gas per mole than a van der Waals interaction occurs in both in organic molecules such as water and organic molecules such as DNA, ethanol, amine, except 3-degree amine, etc. can form each bond with water. So these are soluble in water, although these are covalent compounds. Van der Waals interaction force. The attractive forces among the non-polar molecules in solid or liquid states are relatively weaker compared to normal chemical bonds. The ability of geckos. The ability of geckos which can hang on a glass surface using only one two to climb on sheer substances sheer surfaces have been attributed to the van der Waals forces between these surfaces and spatially or microscopic projections which cover the helixity helixity found on their puppets helixity found on their puppets. Chemical reaction. The process in which substances react to form new compounds products is known as chemical reaction. Types of chemical reactions. Chemical reactions are of following types: combination reactions. In such reactions, two or more substances combine to give a single substance. CO plus H2O, CaOH2, that is CO, that is calcium oxide, H2O water, forms calcium hydroxide. Chemical reaction. Decomposition reactions. These are those irreversible reactions in which a molecule decomposes into two or more simpler molecules, example given 2KCiO3 It makes 2 KCl plus 3O2. Potassium chloride, potassium chloride and potassium chloride oxygen 3O2. Dissociation reactions. Decomposition reaction, dissociation reaction, combination reaction. Dissociation reactions. These are those reversible reactions in which a molecule dissociates into two or more simple molecules to its L. Two, that is H2 plus L1 L2. Hydrogen iodine. Reversible reactions. Reversible reactions are those which occurs in forward as well as in backward direction. Never go to completion. Irreversible reactions occur only in forward direction and go to completion It also contain liquid sodium as coolant. Nuclear fusion is a process which involves fusion of two or more lighter nuclei to give a heavier nuclei. It occurs only at extremely high temperature, greater than 10 per 6 calorie. So also calcium. High temperature, Kelvin. So called thermonuclear reactions. It is used in hydrogen bomb. Energy of sun is also a result of a series of nuclear fusion reactions. Hydrogen bomb. It contains a mixture of deuterium oxide D2O, and tritium deuterium oxide and tritium oxide, deuterium oxide and tritium oxide A2O, in a space surrounding an ordinary atom bomb. The carbon dating. It is used in determining the age of carbon-bearing materials such as wood, animal fossils, etc. It is based on the concentration of C14 and C12 isotopes. C14 and C12 isotopes. Uranium dating. It is used to determine the age of earth, minerals, and rocks. Uses of radioisotopes. Iodine-131 is employed to study the structure and activity of thyroid gland. It is also used in internal radiation therapy for the treatment of thyroid disease. Iodine-123 is used in brain imaging, or iodine-123 is used in brain imaging. Cobalt-60 is used in external radiation therapy for the treatment of cancer. Cobalt-60 is used in external radiation therapy for the treatment of cancer. Sodium-24 is injected along with salt solution to trace the flow of blood. Sodium-24 is injected along with salt solution to trace the flow of blood. Phosphorus 32 is used for leukemia therapy. That is phosphorus 32. Phosphorus 32 is used for leukemia therapy. Cancer in the bone. Carbon 14 is used to study the kinetics of photosynthesis. The carbon 14. Chemical bonding. It is formed by elements to complete eight electrons in the outer shell to complete their octet. It results in decrease in energy and increase in stability. Ions. These are of two types, cation and anion. Cations are formed by the loss of electrons and carry positive charge. Na plus Mg2 plus Mg2 means equal plus. Anions are formed by the gain of electrons and carry negative charge. Cl negative, F negative, etc. Electrovalent bond. Ionic bond, it is a type of chemical bond formed through an electrostatic attraction between two oppositely charged ions. It is formed between a cation, which is usually a metal, and an anion, which is usually a non-metal. That is so many things are here. I'm not going to read it up all. Ionic compounds, okay, they can conduct electricity in molten state or in solution, but not in solid state. They have a high melting point and tend to be soluble in water. They are high melting point and tend to be soluble in water. Examples of such compounds are limestone, CaCO3, common salt, NaCl, lime, CaO, magnesium oxide, MgO, or MgO. The energy required to separate the ions of an ionic compound is called lattice energy. Covalent bond. It is a type of chemical bond that is characterized by the sharing of electrons. Between two atoms. It may be a single bond formed by sharing of two electrons. One electron from each atom. Double bond formed by sharing of four electrons. Two electrons from each atom, or triple bond formed by sharing of six electrons. Three electrons from each atom. The geometry of few covalent molecule H2O water band and H3 ammonia pyramidal CH4 methane tetrahedral CO2 carbon dioxide linear single bond contains only one bond, and double bond contains one, and one by bond, and triple bond contains. Magnetic quantum number. It's just the orbital of a subshell or orientation of electron, and has values from L2 plus L, including 0. Spin quantum number, and it describes the spin of S electron spin up or spin down. W of S can be up or minus of radioactivity. That is 1.43. I'm going outside to pee. Activity. It is discovered by Henry Becquerel, but uh, term radioactivity was given by Madame Curie. Madame Curie. It is the process of spontaneous in disintegration of nucleus and is measured by mm, Geiger counter. It is a nuclear phenomenon, thus remains unaffected by external factors like temperature, pressure, etc. Radioactive rays. Radioactivity involves emission of alpha, beta, and gamma rays or particles and has units Curie, Becquerel, Rutherford upper rays. These rays consist of positively charged helium nuclei. They have plus 2 unit, positive 2 unit charge and for you much. They have low penetrating power but very high ionizing power and kinetic energy. An alpha emission reduces the atomic mass by 4 and atomic number by 2. Thus, the new nuclei formed occupy a position 2 places left to the parent nuclei in the periodic table. So the Fason's group displacement law. Beta rays. These rays consist of negatively charged electrons, and have negative unit charge and zero mass. These are more dangerous than X-rays. Beta rays are dangerous, then more dangerous than alpha rays. These have high penetrating power as compared to alpha rays. Bit that is emission increased the atomic number by 1 with no chance. An atomic mass does turn nuclear obtained. Pauli exclusion principle. It is the quantum mechanical principle which states that no two identical fermions particles with half integer spin may occupy the same quantum state simultaneously, or only two. That was different. Electrons may exist in the same orbital, but these electrons must have opposite spin, and that is often occupy a position one place right to the parent nuclei in the periodic table. So the Poisson's group displacement law. Oh, the battery has become so low. Okay, I don't have wait for today, maybe because of the battery power. It is তোমার দাদা মানে লুচেন কোন আছে মোৰ কিন্তু অলপ পঢ়িলেই আমনি লাগে মানসিক ৰচনে কৈছে মোক এনেকে ৰিড কৰিলে তোমাৰ মনত ৰৈ যায়নে দাদা মানে লুচেনখন আছে মোৰ কিন্তু অলপ পঢ়িলে আমনি লাগে সেইটোৱেতো সেইকাৰণেতো অকলে যেতিয়া পঢ়া হয় তেতিয়া আমনি লাগে সেইকাৰণে এনেকৈ লাইভত পঢ়োঁ কিবা এটা একাউণ্টেবিলিটি ৰেছপনচিবিলিটি অহা নিচিনা হয় সেইকাৰণে আৰু চব বস্তুটো মনত নৰয় কিন্তু মনত নৰলেও মানে ছাবকনচিয়াছ মাইণ্ডত ৰৈ যোৱা নিচিনা হয় আৰু কিছুমান বস্তুটো মনত ৰৈ যায় কিছুমান বস্তু এনেকৈ পঢ়িলে ভালে লাগে প্ৰাঞ্জল লগৰ কি পঢ়ি আছে দাদা মই ছায়েন্স পঢ়ি আছোঁ বৰ্তমান said hi প্ৰাঞ্জল এতিয়া আৰু মই লাইভত পঢ়িব নোৱাৰিম কাৰণ বেটাৰী শেষ হৈ গৈছে মানে মোবাইলত। চ' আজিৰ কাৰণে বাই বাই। আজি লাইকটো কোনেও কৰা নাই দেচোন। কমেণ্ট কৰিছে মানসী ক্ৰিয়েশ্যন এণ্ড প্ৰাঞ্জল লহকৰ। অহাকালিলৈকে আকৌ লগ পাম এনেকুৱা ৰাতিৰ ভাগত। Okay, bye bye. Thank you for watching the video.